dearrangements? So what do you mean by dearrangement? That name itself says that arrangement is not there in the terms. Okay, you are dearranging it. So definition is as it is, a permutation of n distinct objects in which none of the object is in its original place, original position, is called as dearrangements. Say for example, if you take permutation of the integers, say 1, 2, 3, 4, 5, etc. n, in which if 1 is not in first place, 2 is not in the second place, 3 is not in the third place, and so on, n is not in nth place. That is called as dearrangement. That is called as dearrangements. So we'll take an example here and see what is the value of dearrangement, and dearrangement is denoted with small d suffix n, denoted by small d suffix n. So we'll see, start with one object or one number. If there is only one object, we'll continue with that. Say if there is only one object, then you cannot place that in some other place, okay? Because there is only one place and one object. It has to be there only, right? So it will be there in the original place. You cannot dearrange it. Therefore, D1 value becomes 0 and n becomes 1. Here where n is 1, 2, 3, 4, etc. n. So we'll go with n equal to 2. So what is n equal to 2? D2. So what would be the value of D2? So when I take two objects, D2, let me take the number itself here to show the example. 1 and 2. There are two objects, 1 and 2. I can dearrange this, placing 2 in 1, placing 1 in the 2's place, this way. So how many ways I can do this? So this can be dearranged in one way. There is only one possibility. So answer becomes 1. Similarly, D3, let me take n is as 3, and n as 3 means the original places 1, 2, 3. The rearranged places could be of this form. You can change this, place 3 here, place 1 here, place 2 here. That is one option. So what would be other option is placing 2 in one place, 3 and 1. Any other places that you can place? No, you cannot do it. If you try to place in other places, at least one of the element will be in the same original place. So there is only two options, two answers. So D3 becomes 2. Likewise, if you keep doing that, we will be able to get the formula for Dn of this form. Dn where n is greater than or equal to 1 and Dn is nothing but n factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial. General formula they have derived, and it is out of the syllabus scope. So we don't go with the proof for this particular formula. So this was an illustration here. This is an illustration. From this, they have set a nth formula. N factorial into summation k from 0 to n minus 1 to the power of k by k factorial. If you place n value as 1, 2, 3, 4, 5, and you will be getting the dearrangements of all possible dearrangements of that particular case. That is all about definition. So we are moving on to a problem here. Find out the number of dearrangements. This is one of the important question as exam point of view. Dearrangements of 1, 2, 3, 4. Here there are 4 objects called 1 to 4. therefore, the number of dearrangements can be formed by the formula. The formula is as it is, dk is equal to k factorial into summation 1 to k. Okay, so 4 terms to be considered. So you have taken 4 terms, 1 to 4. As per the formula, it has been expanded and simplify that. You get 9 different ways. That means when 4 objects are given, you can rearrange them in 9 different ways. That you can check with or you can validate with following example. If there are 4 numbers taken as 4 objects, then look at this. If you look at all these positions, none of the elements are there in its own original position. Apart from these possibilities, 9 possibilities, if you try to place any other places, at least one element will be there in its original place. Okay, that's why that is not considered as a dearrangement. Here all the elements are not there in the original place. Say for example, here in one place 2 is there, in 2's place 1 is there, in third place 4 is there, fourth place 3 is there. Okay, in the similar way, all other possibilities are there. Similarly, you can also do this problem on your own. Evaluate D5, D6, D7, D8. As per the formula, you can apply and compute the value. Try your